Circle has this equation. We're asked to work out the center and the radius. We can do that all at the same time by writing the equation in the form x minus a squared plus y minus b squared equals r squared. Center a, b, notice the minuses, but we get an a and a b here, and the radius is going to be r. So let's complete the square. X squared minus 10x becomes x minus 5 all squared. Then I need to minus 25. That will give me that x squared minus 10x. And then y squared plus 4y will give, I'll have the 4y plus 2 squared, and then minus 2 squared. And don't forget, we've got this plus 11, and that's going to equal 0. Bring it together, so x minus 5 squared plus y plus 2 squared. I've got 11 minus 29. That's going to give me minus 18. And therefore this is going to equal 18. Or I could even write it as root 18 squared, because then it's exactly in this form. So the center is going to be 5 minus 2. Okay, remember, just like I just take the opposite sign to what's here because of what I had up here. And then the radius is a simplified surd. Well, it's root 18, which I can write as root 9 times root 2, therefore 3 root 2. So the line L has equation y equals 3x plus k, where k is a constant, and we're also told this line is a tangent to the circle. That means it's just going to glance off of it. Find the possible values of k, giving your answers as simplified surds. So there's two approaches to this. You could do implicit differentiation. I'm going to avoid that though, but I will talk a bit about it at the end. The second way is to use the fact that the tangent just glances off of the circle. There's going to be a repeated root. What we can do is solve them simultaneously, this equation, and I'll probably go with the original equation, and then look at the discriminant, set that equal to 0, because that's when you have equal roots. Let's do this. So I'm just going to replace all of my y's by 3x plus k. X squared plus 3x plus k squared minus 10x plus 4 times 3x plus k plus 11 is going to equal 0. Expand that out. So I've just expanded this double bracket out. Okay, now let's tidy things up. We've got x squared and 9x squared to give me 10x squared. I've got minus 10x plus 12x, that's going to give me 2x. And then I've got a 6kx as well. I'll just do them a bit, do that for now. And then k squared plus 4k plus 11 equals 0. Right, there's just one more step I need to do, because I want to be able to use the discriminant. So I need to get my coefficients a, which I have 10. I've got c, that's going to be this bit here. But I just need to bring this together. 2 plus 6k times x. Now that's going to be my b. B squared minus 4ac, the discriminant, is going to equal 0, since there is one point of intersection. Just a reminder, if you had a circle and a straight line and there were 2 points of intersection like this, the discriminant would be greater than 0. If there were no points of intersection, it would be like this. But we're looking at a special case, a tangent, where there's this one point of intersection. So 2 plus 6k all squared minus 4 times 10 times k squared plus 4k plus 11 is equal to 0. I could make my life a little bit easier by factorizing out the 2, because I can square them separately and then I can cancel the 4's, just so my numbers aren't quite as big. Don't worry if you don't spot that, or if you prefer to not do things like that. Right, now I expand this bracket, so 9k squared plus 6k plus 1 minus 10k squared minus 40k minus 110 is equal to 0. So minus k squared minus 34k, and then I've got 1 minus 110, so that's minus 109 is going to equal 0. Just swap these around, so it's k squared plus 34k plus 109 equals 0. Right, there's no way this is going to factorize. Does it say in the question anything about... It does even say they're going to be surds. So we can just use the quadratic formula. I was just checking if we had to show detailed reasoning, but even then I think it's okay for this sort of thing. We get minus 17 plus 6 root 5, or it's going to be minus 17 minus 6 root 5. You could do plus or minus, I've just decided to write them separately like this. And both of these are absolutely fine, because there would be, remember, we've got this constant gradient, but actually I found this one at the bottom, but there would be one if I kind of moved the intercept up that would hit it there as well. That's why I've got these two solutions. Of course, you could put it in the quadratic formula by hand. And yeah, don't forget about this. Minus b plus or minus b squared minus 4ac. But when we're dealing with A-level, it's absolutely fine to just use that little function just to speed things up. Well done. Just going to talk about other methods for doing this question. I did mention it before, but we could use implicit differentiation on the circle, which gives you this. See, I don't think it really makes things any easier. Make dy by dx the subject, and then set it equal to 3, because remember, the gradient, the tangent was 3. We're going to get this equation here, which we can combine with the equation of the circle to get a quadratic, which will lead to a solution for x and y, and then put that back in to work out k. That feels pretty complicated, but it would work out. Even more complicated is to do exactly the same thing with implicit differentiation, but instead of combining this equation with the circle, combine it with the tangent. That gives you a solution for x and y in terms of k, which you then put back in to the circle, and then you can work out what k is from there. Okay, that's another possibility. Finally, a fourth method for doing this question. So I drew a little sketch before of the circle and the tangent. Now we know the tangent gradient is 3, which means the normal gradient is minus a third. And that normal will necessarily go through the center. So this method uses that approach, minus a third, and then we can construct an equation for the normal. And then we can also, we know it goes through the center, but then we can solve it with the circle again and get x and y values for where it hits the circle, and from that work out k. Again, it's just quite involved, but these three methods work as well. I personally would stick with the discriminant. Anyway, hopefully that makes sense.